Rocks are the most common material on Earth. They are naturally occurring aggregates of one or more minerals, and they can be found all over our planet. Rock divisions occur in three major families based on how they are formed. Those three families being igneous, sedimentary, and metamorphic. Each group contains a collection of rock types that differ from each other on the basis of size, shape, and arrangement of mineral grains. The rock cycle is an illustration that is used to explain how the three rock types are related to each other and how Earth processes change a rock from one type to another through geologic time. Plate tectonic movement is responsible for the recycling of rock materials and is the driving force of the rock cycle. The first type of rock that we will be discussing is the igneous rock. The word igneous translates to fiery. There are places on Earth that are so hot that rocks melt to form magma. Because magma is liquid and usually less dense than surrounding solid rock, it moves upward toward cooler regions of the Earth. As the magma loses heat, it cools and crystallizes into an igneous rock. Magma can cool on the Earth's surface, where it has erupted from a volcano, or under the Earth's surface, where it has intruded older rocks. The composition of magma is limited to the 8 common elements of the Earth's crust. These elements combine within and melt to form silicate materials, the most common materials of igneous rocks. These silicate materials include feldspars, quartz, micas, pyroxenes, amphiboles, and olivine. These minerals make up over 95% of the volume of the common igneous rocks, making igneous rocks easy to identify. The next type of rock we will be discussing are sedimentary rocks. Any rock exposed at the Earth's surface can become a sedimentary rock. The forces of wind, rain, snow, and ice combine to break down or dissolve and carry away rocks exposed at the surface. These particles eventually come to rest and become hard rock. Sedimentary rocks tell us what the Earth's surface was like in the geologic past. They can contain fossils that tell us about the animals and plants or show the climate in an area. Sedimentary rocks are also important because they may contain water for drinking or oil and gas to run our cars and heat our homes. The final type of rock that we will be discussing is the metamorphic rock. Any rock, igneous, sedimentary, or metamorphic, can become a metamorphic rock. If rocks are buried deep in the earth at high temperatures and pressures, they form new minerals and textures all without melting. If melting does occur, magma is formed, which starts the rock cycle all over again. The term metamorphic means to change form. Changes in temperature and pressure conditions cause the minerals in the rock to become unstable, so they either reorient themselves into layers, which is called foliation, or recrystallize into larger crystals, all without undergoing melting. Geologists can learn a lot about the Earth if they study metamorphic rocks. Some of these things can include the temperature and pressure conditions, aka the metamorphic environment in which said rock was formed, the composition of the parent or original unmetamorphosed rock, and this actually aids in the interpretation of the plate tectonic setting in which the metamorphism took place, and this also aids in the reconstruction of the geological history of an area. All in all, the rock cycle is an important aspect of our dynamic Earth because it enables rocks to change to different types of rock depending on their location and circumstances. So in other words, it helps rocks recycle themselves so that new structures can be built as the Earth's surface changes from plate tectonics.